Hey guys, today we are going to be covering the first section of chapter 8 from our textbook. Chapter 8 has to do with rational expressions and equations. We've seen them a tiny bit before. Now we're going to go in more depth, figure out how to add, subtract them, solve equations with them, graph them, things like that. So section 1 is all about multiplying and dividing rational expressions. Now, let's define that first. What is a rational expression? Well, we know what an expression is. But rational means fractional. It can be written as a fraction, kind of like we saw with rational exponents. So a rational expression, as you see here on the left side of the screen, those would be expressions where we have a fraction, specifically most of the time, expression in the numerator, expression on the denominator. 2x over 4x minus 2, for example, is a rational expression. Now, one of the things you're going to need to know for a bunch of this chapter, graphing and solving, is where is this rational expression undefined? Where does it not exist? And the good news is we already kind of know how to find that. Undefined is wherever we would be dividing by 0. In the past, in chapter 7, we called this restricting the domain. Now we're just finding where would this be undefined? So I'm going to say 4x minus 2 would equal 0 when it's undefined. 4x equals 2, divide by 4, x equals 2/4 or 1/2. So for this very first rational expression on the left-hand side of the screen, undefined at x equals 1/2, because that would make the bottom 0, meaning we would be dividing by 0. How about the second one? 2x plus 1, if I'm looking for undefined values, I would say 2x plus 1, where does it equal 0? 2x equals -1, x equals -1/2 there. So undefined at x equals -1/2 on this second problem. So notice we don't really care about the numerator at this stage. We're only looking for undefined values, meaning when are we dividing by 0? Now let's just make things a little trickier, bump it up a notch. What if it's a little more complicated? Y plus 6 times y squared minus 8y plus 12. Where is that rational expression undefined? Well, it's going to be in multiple places. The first one, not too bad, because where would y plus 6 equal 0? When y equals -6. So that's one undefined value there. Where else though? How would I find where y squared minus 8y plus 12 equals 0? Well, the good news is this is what chapter 5 is all about, solving quadratics. This is a quadratic. I need to know when does it equal 0? And my first go-to, especially when it looks like I can factor, is factoring. Y squared, y and y, signs are the same, they're both minus. Multiply to be 12, add to be -8, -6, -2. So y would equal 6, y would equal 2. Both of those values would also give us a 0 on bottom. So looking at this rational expression is undefined at y equals -6, 0, or 6, or sorry, not 0, 2. -6, 2, or +6. There were 3 values where this one was undefined. Any value that makes the denominator 0. You're going to have to commonly factor in this. You're going to have to set different factors equal to 0 in the denominator. But this is where we stand. Undefined values, where does the denominator equal 0? Sorry, what would make the denominator equal 0? So a big part of this section is multiplying rational expressions together. Quick 2-step process here. If you can factor, factor. We can't on this first example, but we will be able to on the second one. And then if you can, cancel things out, cancel top to bottom, cancel diagonally. We're going to see and get lots of practice with this. So First problem here, and you can jot it down in your notes, 9m squared n cubed over 16a b to the fourth times 8a squared b over 27m to the fifth n. Let's start canceling. First thing I see, they're diagonal, but remember when we're multiplying, we would just multiply straight across, so we can totally simplify diagonally. 9 over 27, 1 over 3. Divide them both by 9. Similarly, 8 over 16 is basically 1/2. What about our m's? Our m's, we have m squared on top, m to the fifth on bottom, so 2 of those could divide out. I can kind of cancel 2 of those out, leaving me with m cubed down here, because I canceled 2 out of those 5, leaving me with 3. I'll go green, n cubed over n. We have 3 on top, 1 on bottom, so we will end up with 2 on top. And then now let's go to the a's. A squared over a. Get rid of one of the a's on top and bottom. That leaves us with 1a on top. And then the b's, there's 1b on top. There are 4 b's on bottom. We'll make that b cubed on bottom. So final answer, multiply straight across. 1 times 1 is 1. A n squared over 2 times 3 on bottom is 6. B cubed m cubed is what I'm getting. So this section is going to be a lot of canceling, a lot of factoring if we can, and then a lot of canceling. Let's see one where we do have to factor. Y minus 1 over 5y plus 15 times y squared plus 5y plus 6 over y squared plus 4y minus 5. 2 things you should not do. Please, please, please remember that we can't just go, oh, y, y. We can't just divide individual terms out of a polynomial. That polynomial, those are all linked with pluses and minuses. We can't do that. The other thing you should not do is to start multiplying and distributing and pulling one of those. Much easier way to do this. Check it out. On the left, y minus 1 over, I'm going to change that bottom to 5 times y plus 3. Just factoring out of 5, right? What about top right? What would that factor into? Well, how do we get y squared? Y and y. Signs are the same. They're both positive, so plus and plus. Multiply to be 6, add to be 5, 3 and 2. So we'll factor that top. Take a second, factor the bottom. Pause the video if you need to. Just, again, work on those factoring skills. And then I will go ahead and do it. Y and y. Signs are different, plus and minus. Multiply to be -5, add to be +4, 5 and -1. Now, why was this super convenient? Because we have a y plus 3 on bottom here, y plus 3 on top. Y minus 1 on top, y minus 1 on bottom. And so by factoring, we can see that this just comes out to be y plus 2 over 5 times y plus 5. And simplified that multiplication of rational expressions. I would probably leave it like this on bottom. Could you multiply that out and say 5y plus 25? You could, yes. However, for reasons you don't know yet, but we will see in a future section in this chapter, it will oftentimes be a lot more convenient just to leave the denominators factored. So I'm just going to leave it 5 times y plus 5. So multiplying, these were kind of our 2 examples. That top one, we couldn't factor. They were not polynomials. Each numerator or denominator was just a monomial. There are no pluses or minuses, but if there are pluses or minuses, try to factor, then cancel. In any case, both of them just turn into canceling games. Well, then what changes when we talk about dividing rational expressions? Good news? Not much. How do we divide fractions in any case? Copy dot flip, right? Multiply by the reciprocal. So that's going to be my first step here. I'm going to copy the first one, 18ab squared over 25x squared y cubed, dot flip my second rational expression, 10xy over 9b. And now this looks almost exactly like that very first problem we worked 2 problems ago, right up there, the colorful one. No pluses or minuses, so we can just start canceling different variables and numbers. I want you to pause the video. Try this. Try canceling stuff out. See what you get. When you are ready, unpause it. I will do the same. All right, I have put my work on the screen, and hopefully you had a chance to work this out. When I started copy.flip and now it's just a canceling game, canceled some numbers, divided factors out, same with those variables. I got 4ab over 5xy squared. One common mistake I just want to warn you against, one common, I don't know if mistake's the right word, oversight maybe, is if you forgot the a in the numerator. Notice that there was nothing for us to divide out with an a. There was no a on bottom. It's really easy just to miss that a on top because we were canceling and putting things in different colors in my case. That a right here, make sure that it's still there. We didn't cross it out. Make sure you include it. But hopefully that looks good. Compare your answer, your work to mine. And then if you have questions, obviously, I'm hoping you will come to me with those next time we meet. Let's do another division one, another copy.flip with rational expressions. And it's going to look scary, but it's actually not. Yes, there are a lot of fraction bars in there. Y minus 7 over y minus 3 divided by y squared minus 49 over y squared plus 4y minus 21. Well, if you recognize that this is a fraction divided by a fraction, a rational expression divided by a rational expression, we can just say that this is y minus 7 over y minus 3, copy dot flip, plus 4y minus 21 over y squared minus 49. Now, if you're feeling confident, go ahead and pause the video, work it out yourself, and then see if you get what I get at the end. If you're still a little shaky, maybe with the factoring, maybe with this process, feel free to follow along as I do it now. Step 1, factor. There are only 2 steps, and that was step 1. So y minus 7, that's linear, it won't be factored. Y minus 3, linear, nothing to pull out, that won't be factored. Y squared minus 49 in the bottom right, that is a difference of 2 perfect squares, and I hope you recognize that. Y plus 7, y minus 7. So difference of 2 squares, square root of the first plus the square root of the second, square root of the first minus square root of the second. And then top right, kind of a more sort of conventional factoring problem. How do we get y squared, y and y? Signs are different. We need to multiply to be negative 21, add to be 4. So that'd be 7 and 3 with the 7 being positive. So we end up with more 7s, plus 7 minus 3. And where does that leave us? Well, y minus 7 on top left can cancel with y minus 7 on bottom right, and y plus 7 on top and bottom of my right-hand rational expression. And y minus 3, top right and bottom left. And when we cancel all these out, remember, whenever we divide top and bottom, it equals 1. So what do we get? We get 1 times 1 times 1 over 1 times 1 times 1. This is just a fancy, fancy, complicated way to write 1. It all cancels out. Not a super hard problem if you know how to copy.flip and how to factor. So hopefully that one went well, and hopefully maybe serves as an example for, it might look complicated, but really it's not the worst thing ever. I've got one more case that I want to show you, and that's sometimes you might need to factor out a -1 for things to work out nicely. Now this is not a hard thing to do, but you got to be able to recognize it. So our problem says simplify 2x minus x squared over x squared y minus 4y. So step one, let's factor on top. We can definitely pull an x out, and sometimes we forget that that's factoring. Well, this is x times 2 minus x. And then on bottom, we can pull a y out. So that's y times x squared minus 4. And then I might recognize, wait a second, x squared minus 4, that's a difference of 2 squares. Y, I can say x plus 2, x minus 2. Again, factoring, important. Okay. Where do we go from here? There's nothing really to cancel, unfortunately. It's close. We have a 2 minus x on top and x minus 2 on bottom. So what do we do here? Well, here's my recommendation, and here's how you can think of it. If we just need to flip all the signs in one factor, right now we have positive 2 minus x on top, positive x minus 2 on bottom, that's when you know that maybe you should just factor out a negative 1. And here's what I mean by that. X times negative 1, and I'll write it in the same order, times negative 2 plus x for my numerator. Look at this factor right here in blue, and I'd like you to convince yourself that it matches negative 1 times negative 2 plus x. Because when we pull a negative 1 out, it just flips all the signs, right? We've seen that before. We've seen that many times. So by pulling that negative 1 out, it becomes negative 2 plus positive x. It still doesn't look exactly like the things we have below, but if we rewrite it, just take one more step, we could write it x minus 2. We could just flip their order. Negative 2 plus x, x minus 2, y, x plus 2, x minus, forgot a parenthesis, x minus 2. Now they're gone. And now we can just simplify top and bottom. So that'd be negative x on top over y times x plus 2. This is kind of a special case. And how do we know when we might need to factor out a negative 1? When we almost have matching factors on top and bottom, but the signs are just all wrong. In this case, we had in blue circled there on the right, 2 minus x on top, and then we had x minus 2 on bottom. So to flip their signs, we said, we'll just pull a negative 1 out of the top. And that changed their signs, made it x minus 2, so we could cancel. So these are the nuts and bolts. Really, 8.1 comes down to, do you know how to work with fractions, copy, dot, flip, multiplying, dividing, and do you know how to factor? Those are the two big skills that we need to look for in 8.1. You guys are going to have some practice problems. Take a good look at them, hopefully complete them. If you do have questions, bring them to our next class period so I can help you out with that. But make sure you're asking them. Don't just sit on it and hope that you understand it in the future. That's not really how it works. But guys, that is all for 8.1. Give those practice problems a try, and I will see you next time.